Hey guys, we're back with notes for 2.3. We're actually going to break this into 2 days, so this is going to be the first notes video. There's 3 pages that this is over. So if you will take just a second, I'm going to have you pause this screen and copy everything that you see. Okay, once you have this all written down, let's go ahead and talk about it. So we are talking about domain and range today. These are vocab words that we wrote on those doors back the first day of the unit. So domain is all the X values. Range is all the Y values, okay? So when we list those out, we're going to have to make a couple decisions. First decision we're going to have to make is what kind of data do I have? I can write domain and range for both kinds, but it's going to change how my setup looks. So if we focus just for a second on anything that's discrete, okay? Discrete data is going to be anything I could count. A few examples of that, you don't need to write this down, but a few examples of things I could count is I can count how many people are in a class. I can count how many cars are in a parking lot. I can count how many trees are in the courtyard. All of those are discrete data, okay? When we look at a graph for discrete data, what we're going to be talking about is the dots on the graph. The dots cannot be connected. They need to be specific XY coordinates. So if I was looking at this problem and I was going to list you out the dots, I have -4, -3. That's my first point down here. I have -2, 0. That's this point. I have 1, 1. That's this guy. And then I have 2, 3. That's my final guy. So when I list the domain and range for discrete data, I'm listing out all of the X's that I see. So my domain would be these numbers. I list them out from least to greatest, and I make sure that none of the numbers repeat. Okay, so -4, -2, 1, and 2. My range, on the other hand, is all my Y values from that point. So all my Y values would be here, -3, 0, 1, and 3. Again, least to greatest, making sure they don't repeat. Discrete is probably the easiest ones because we're comfortable writing points, and it's really, really easy to list out numbers. Okay, so that's discrete data for domain and range. The second kind we have is continuous. So let's talk about continuous for a second. Continuous data is anything that you can measure. So a few examples of continuous would be like the height you are growing up. It could be like the temperature outside. It could be like the distance that you're going to drive on a road trip. All of those are things that you would have to measure. Okay? You don't need to write that down. If you did, that's okay. But they're anything that you can measure. When we talk about a graph for continuous, it's not going to be specific dots. You might have a dot on the graph like we do here, but they're going to be connected with a line or a curve. So when we list out our X's and Y's, it's not going to be a list of numbers. It's going to be a whole area. So for instance, if I was talking about the domain on this graph right here, I would be saying the smallest X that I get to use is -4. And I want to say how big to the right do I use with my X's? I actually go forever. If my graph was bigger, I would keep going. Okay? For the Y's, we would be saying, well, the smallest Y and the biggest Y. Well, for my Y-axis, I would go off the graph down here on the bottom, but the biggest Y that I ever get to is 4 right there. So it's kind of asking you to screen in which X's and Y's get used. Notice that on this graph, I never used anything. None of my X's out here in the -5, -6 range. I never used any of my Y's up here in the 5 and 6 range. Okay? So it's going to be what I call a sandwich. We're sandwiching the X between the smallest and biggest values that it can be, and we're sandwiching the Y's between the smallest and biggest values that he can be. We're going to do lots of examples, so I know this is very general. As far as the questions that you're going to ask yourself, I want you to take a second, pause, and write this down. Okay, so this is explaining the same thing that I just told you. When you're writing discrete data, when you see dots on a graph, you're going to ask yourself to write out all the points, X, Y. Then you're going to order the X's least to greatest, order the Y's least to greatest. If you have a continuous, like a curve or a line, that's when we're going to ask ourselves, how far left and right did I go on the x-axis? How far down and up did I go on the y-axis? Remember, down is the negatives, up is the positives. And then we're going to make sure that we look for those closed circles if they're or equal to, or if we actually touch the number that we're talking about. You guys are going to see lots of examples for that. If you have that all written down, go ahead and meet me on the next page. All right, so we're going to go ahead and separate by colors, domain, and range. That's how I'm going to order my information. So if you would, on problem 1, let's decide, is number 1 discrete or continuous? Well, I see more than dots. I see a curve, so I'm going to put a C. This is continuous. So when I know that, I'm going to start by setting up my X in a sandwich. Kind of at the same time, I'm going to do number 2 for that one also. He's continuous. I'm going to set up my sandwich. I'm going to do the same thing on the Y's. So let me change colors. My Y's are going to be sandwiched. I'm using less thans because we're going least to greatest. Same thing on number 2. So let's break this down. Your goal is to figure out what is the smallest X I go and what is the biggest X I go. So let's look at number 1 first. If I follow these arrows and I start with this guy, where is this arrow going as I trace him? Well, it looks like I'm moving to the left and I'm also moving up. So I'm going to break him into 2 separate arrows. There's an arrow moving out, and this arrow is also moving upwards, okay? Whenever you have an arrow, we're going to use an infinity sign. So think about your axes. Let me zoom in real quick. Think about your axes. Remember, you have positives and negatives. So those are going to follow the same way. Negative infinity goes left, positive infinity goes to the right. Same thing with the y-axis. You have negatives and positives. So positive infinity goes up, negative infinity goes down. Okay? So if you're ever curious about where I'm getting those from, it's following the direction of the numbers on the graph. Okay? All right, so if we're looking at problem 1 and we see an arrow going left, that means it's going to go forever to negative infinity. If I look on the right and I trace the arrow, I notice that it's moving to the right and it's moving up. So I'm going to give 2 arrows, an arrow going up and an arrow going to the right. An arrow going to the right for the x's is going to mean that he goes forever to positive infinity. We have a shortcut name. Whenever you say the x's go forever, they go forever left to negative infinity, forever right to positive infinity, we're going to bring back one of the old symbols we used in in unit 1. We're going to call this all real numbers. Basically, X can be anything. If I had a bigger graph, that graph would cover the entire paper. Let's talk about the Y's. On the Y's, we're talking about how far down I can go and how far up I can go. So if I'm talking about my Y's and I'm saying how far down can I go, I never get down here in this zone. I never get to the negatives. The lowest Y that I ever use, the lowest point, is right here. What Y number am I hitting? Well, I'm hitting a positive 1 on the y-axis. And if I look up at my arrows, it looks like I'm going up with arrows, so that would take me up to positive infinity. So the farthest down I go is 1. The farthest up I go is positive infinity. I'm not going forever. I don't get to use all real numbers again. But I am going from 1 all the way up forever. So the last question that we're going to ask ourselves is, are there any or equal to's? So right here, and I'm going to highlight it, right here, because we did touch positive 1. There's a closed circle there, but we did touch that wall at positive 1. We're actually going to go up here, right under this symbol for the 1, and we're going to put an or equal to with it. I want you guys to make yourself a note that you can never be equal to with an infinity, okay? You can never have an or equal to with an infinity. Positive or negative, you cannot have that, okay? Let's look at problem 2. Problem 2, I have arrows again, so let's figure out where our arrows are going. If I trace this first arrow, he's moving left and up at the same time, so I'm going to make notes. He's going up and left. If I trace him downward, he's going down and right at the same time. So if I ask you how far left do the x's go, that would be negative infinity. It's an arrow. If I ask you how far right the x's go, that would be positive infinity. There's an arrow. When we have double infinities, that's when we use all real numbers. It will not always be that answer. It just works out if you have arrows on both sides going left and right for the x's. Okay? Let's talk about for the y's. For the y's, how far down and up does it go? Well, all the way down, it goes all the way to negative infinity because I have an arrow. For how far up, it goes all the way to positive infinity because I have another arrow. When we have double infinities again, we're going to use all real numbers. It does not always come out that way. We saw that on problem 1. But if you have an arrow that's going down and an arrow going up, that's going to mean your range is all real numbers. Okay? If you ever need to pause this and listen again, feel free to do that. I'm moving on to question 3. All right, question 3 and 4. I noticed that both of these are discrete. Because they're discrete, I'm going to have to start this problem by listing out my x's and y's. So let's do that on this first problem. This is number 3. So if I list out my points, I have negative 3, 3. That's this guy. I have negative 2, 2. This guy. 0, 0 in the middle. 2, 0. And 4, negative 2. So to do domain and range, all you do is list out your x's and list out your y's. X's are first, so we're going to write that out in order, least to greatest. We got negative 3, we got negative 2, 0, 2, and 4. We are done with x's. We're going to do the same thing with our y's, least to greatest. I got negative 2, I got 0. I am not going to repeat them, okay? We are not going to repeat this other 0. We only list it once. So afterwards, we would have 2, 3, and we are done. Those problems are a lot quicker, a lot easier. As long as you can list out ordered pairs, we're going to be in good shape for these. Okay? Let's try number 4. I'm going to list out all my points. I have 6 of them. Okay, so our first point is going to be negative 5, negative 5. Then we've got negative 3, negative 3. Negative 2, 0. 1, 2, 3, 2, and 4, 4. So on problem 4, we're going to do the same thing again. We're going to list out our x's, list out our y's. Make sure you are going least to greatest with no repeats. All right, so least to greatest, we've got negative 5, negative 3, negative 2, 1, 3, 4. No repeats in that one. We're in good shape. Let's do the same for our y's. So we're starting smallest. Negative 5, negative 3, 0, 2. Don't repeat the second 2. We go straight to 4, and that is the end of our answer for number 4. Okay? Listing out your x's, listing out your y's. Okay? All right, problems 5 and 6. First thing I'm going to do is label with my arrows. Okay? So notice I am talking about this line right here. He's the one that goes through the graph. It's not the axis. It's the graph that's drawn on top of it. Okay, so if I label my arrows, that graph isn't going up or down at all. It's just going straight left and straight right. So is that discrete or continuous? Hopefully you're saying continuous, which means I want to make my sandwich. Sandwich my x's, sandwich my y's. For the x's, I'm going to be asking how far left and right does it go? Well, left has an arrow, so that's negative infinity. Right has an arrow, that's positive infinity. Whenever we have the double infinities, that's all real numbers. I promise you it will not always be all real numbers. For the range, we're talking about how far down and how far up this graph goes. This one's a little tricky. Let me zoom in real quick. Okay, so if I ask you, did that graph ever make it down here to negative 6? No. Did it make it to negative 5, negative 4, negative 3, negative 3, negative 2? Did it ever go below negative 2? No. So -2 is the lowest that it ever went. Okay? If I move this and I ask you, did it go up to 6 or 5 or 4 or 3, 2, 1, 0, -1, -2? It never went higher than -2. Now, we cannot give answers that say y is between -2 and -2. You can't be bigger and smaller than the same number at the same time. So when these are the same, I'm going to rewrite this, and we're just going to say that means that y is always equal to -2. He can't be greater than it and smaller than it. He is staying equal to that -2 the whole time. Okay? So if your bottom and top are the exact same number, we change it to an equal sign. And we are done with problem 5. Let's look at number 6. Number 6, is this discrete or continuous? Hopefully you're saying continuous because you do have a line or a curve. We're making sure that we're looking, the dots are there, but they're connected with a line or a curve. So I'm going to sandwich my x's again. I'm going to sandwich my y's, except this time I don't have any arrows. So if there's no arrows, there's no infinities, which means that I'm going to have numbers in all my blanks. So let's look on the x-axis. I'm looking right here. On the x-axis, if I drew a line, if I drew a line and I asked you, did this graph make it to -1? Yes. -2? Yes. -3? That's where it stopped. So the farthest left that that graph went was -3. That's my first number. If I ask you how far right did it go, did it get to 1, to 2? 2 is as far as it went. It got all the way to +2. Okay, so left was -3, right was +2. Think about it like cropping off a picture. I don't need any of this. The graph did not go in that zone. Okay, for the y's, we're going to do bottom and top. Okay, so if I ask you on this first guy, did that graph get to -1, -2, -3, to -4? Right there. So -4 is the farthest down that my graph goes. It never went past that. Okay, let's see how far up did it go. So did that graph get to 1, 2, to 3? Right there. So +3 is the highest that it ever went. That's the farthest up. Nothing above that got used by my graph. All that picture right there, all of it fits within this space right here. Okay? So the last thing that we would ask ourselves is, are there any or equal to's? Okay? So I'm going to take all this mess out here. And I would ask you, for the x's, did you actually hit that -3? No, it's an open circle. Did you hit the +2? Yes, that's a closed circle. So we're going to come up here. And right there, underneath that less than, I'm going to put an or equal to. What about the y's? So on the -4, did I hit -4? Yes, there's a closed circle. So right up here, we're going to put a or equal to on that guy. Oops, it's hard to see. Or equal to. And then I'm going to ask, did I hit the 3 up at the top? No, that's an open circle. I did not touch that point. So that is my final answer. The last thing you're looking for is, do you have or equal to's? Okay. All right, if you missed anything on here, feel free to pause it where you need it. Otherwise, I'm going to meet you on 7 and 8. All right, so 7, 8, 9, and 10, these are all continuous. So right now, can you do me a favor? Set up all your X sandwiches and all of your Y sandwiches. We're going to do a lot of practice on these ones. So X's are your domain. Put your less thans in there. Y's are your range. Make sure you put your less thans on both sides. All right, so if we start on problem 7, I'm saying what's the farthest left and right that graph goes? So the farthest left that it goes, it gets past -1, -2, -3, -4 is the farthest left. There's no arrows on this one, so no infinities. The farthest right that it went, well, it did not get to 5, it did not get to 4, or 3, or 2. The farthest right that it went was 1. So I would say the x stays between -4 and 1. He stays only between them. For the y's, I'm going to do the same thing. So on the y's, I never got to -5, 4, 3, 2, 1. Nothing down there. I never got to 0. But I did get to a +1. The farthest up I go, that's not this dot. I actually got higher than that. I got all the way up to 2, 3, 4, 5. I got all the way up to 5. So all of my y numbers stay between 1 and 5. Last thing we want to look for is, do I have any or equal to's here? Well, if I go back and I say, well, did I hit this 4, this -4? Yep, closed circle. Did I hit the 1? Yes, closed circle. Both of those are or equal to then. If I ask about the y's, did I actually hit this 1 down here? There's no closed circle, but I did touch that line, so we are going to do or equal to. Did I get to the 5 way up here? Yep, there's a closed circle. He is or equal to. So one more time, you put or equal to if you have a closed circle or if you touch the line. The only time you will leave them as a plain less than is if it's an open circle or an infinity. Okay? All right, let's do number 8. Number 8. I'm looking at this one and I notice that I have arrows down here, right? All right, so if I trace that arrow and I move all through this, I notice I'm moving to the right and I'm also moving down. So if I think about moving to the right, that's a positive infinity on my x. And if I think about moving downward, that's negatives on my y, which means we only have 2 numbers to fill out. So on the x's, what's the farthest left? Not -5, -4, none of these got used. 1 didn't get used. 2 is the farthest left that I went on my graph. He's got an open circle, so we're not going to put or equal to, and we can't put or equal to on this positive infinity. Okay? Next comes for my y. So we already did the negative infinity. That's going down. But how far up did the graph go? Well, it got past this 2, right? It went up to 3, up to 4, up to 5. That's the highest place on my graph. And because it went up to 5, bounced off and turned around, it touched the the positive 5 line. So we are going to put or equal to on that one. So negative infinity less than y less than or equal to 5. Okay, that's problem 8 for us. We got 2 more. Please stick with me. Problems 9 and 10, neither of them have arrows, so there are no infinities on this problem. For the x's, if I say all my numbers on that curve stay between what left and right? Well, it stays between -4 and 1. So -4 is on the left, -1's on the right. Both of them have open circles, so there's no or equal to's. For the y's, I'm moving down and up. So the farthest down that graph goes is -1. The farthest up it goes is all the way to 3. Make sure you're not stopping at that point. You're going all the way up to +3. So down, -1, up to 3. -1 has an open circle right here. That's not or equal to. But 3, right here, he does touch and bounce off of that line. So next to my 3, I am going to put an or equal to. So because it touched, I put an or equal to right here. That is my final answer. We have one more question. Number 10, if I say what's the farthest left that we went to? Well, I moved all the way to -2, and I go all the way to +2. I stay between those numbers. There are open circles at both of them. Sorry, there are closed circles at both of them, so I'm putting or equal on both of them. Okay? For the y's, the farthest down I went was -4. The farthest up I went was -2. I stayed between those numbers. So -4 is down, -2 is up. I have a closed circle and I bounced off the line. So both of those are going to get or equal to's. Okay? If there's anything you missed, feel free to go back and look at those. Otherwise, you can get started on practice 1 of 2.3.